Hey guys, welcome back to my channel, and in this video I want to share with you some graphical effects that I was able to implement using shaders in my game. As you know, I develop game engines as a hobby, and I'm also developing the first game with the Untitled engine, so I'm super excited for that. But there's one thing that I've been wanting to improve, and that is learning more about shaders. So I have taken the time to learn more about shaders and implement some shading effects that I really like. For example, I'm sure that you have seen this whenever you play FIFA, especially when you are in training mode. You may have noticed that if you dribble beyond the boundaries of the lines start flashing. Well, whenever I saw that, I really liked that effect, and I wanted to know how you can recreate that in your game. So after 5 seconds of thinking about it, actually that was after 5 hours actually, after 5 hours of thinking about it, I was able to duplicate the same effect, and I want to share that with you. I want to share with you how you can implement this in your game or in your game engine. So let's begin. Before I begin, I want to share with you this website that has really helped me now that I'm learning more about shaders. It's called GraphToy. It's a website that will help you visualize the functions that are used in the shading language. I really recommend you to make use of this because it has helped me a lot to visualize and and see the effects that I will be able to create with the particular function. And I'm also going to be using this particular application called Code Live. You don't have to use this, you can use ShaderToy if you want to. And I'm also going to be using the Metal shading language. And again, the language doesn't really matter. What really matters is that you understand the concept, the idea, on how to approach shading and how you can create some effects, right? So don't worry about the language. The whole point is the idea behind them. All right, so let's begin. So as I mentioned before, we are going to be making use of 4 functions: modulus, floor, fract, and the step function. And again, I'm going to be using this website so that you can actually visualize how the function behaves. And the first function that we are going to be working on is going to be the modulus function. And the modulus function, if I will type this out, would behave like this. Right? So what does this mean? Well, it basically means that at 0, right, we are going to see black, right, at the start, and then it will slowly ramp up to 1, which is white. So what we're going to see is kind of a gradient. So if I would come to this application here, and if I would type that function, and let's say I go float c mod SDX, because that's my x coordinate for my space 1, and if I would render this, what I will get is just like I showed you previously. The graph showed you that it will start from black, right, all the way to 1, which is in this case will be 1. All right. But obviously you may wonder, oh, how am I going to create the dash line effects using this? Well, that's where we are heading. The other function that we are going to make use of is the step function, and the step function behaves like this. So a step, let's say I do 0.5x, right? What I will get will be this behavior. And one tip for you to keep in mind is that whenever you see the step function, you can, assume it acts as an if statement. All right, this function is basically saying if x is greater than 0.5, then return a 1. If it's less than 0.5, then return a 0. And that is exactly what it is doing here. Whenever x is greater than 0.5, it returns a 1. If it's less than 0.5, it returns a 0. Okay, and what do we get when we do that? Well, if I would also show you this behavior, let's say step 0.5 SDX, and then I render the step function, we get something like that. Okay, now what we're going to do And again, right, this is the 0, which is black, and the white, which is going to be 1. Well, what happens if we combine these two functions? What do we get, right? Let's say that instead of x, I'm going to say modulus of x 0.1, right? What do we get when we have those two? The step function now became periodic, and we can make use of this to create the dashed lines that we want. For example, we're going to have black, white, and that is the effect that we are going for, right? So I'm going to actually combine these two into one, so you see how this works. So what I want to do is, instead of saying STX, I'm going to say modulus st.x 1.0, right? And now we get something like that. But you're going to say, well, nothing really changed. Well, it did, because now what I can do, I can increase this, but we don't want this. What we really want now is we want to somehow be able to only show a particular section of the whole canvas here that will contain the dashed lines in this case, right? So how can we do that? Well, now we can use the step functions again, but instead of applying it horizontally, we're going to apply it vertically. So let's say I do float L step, and now I'm going to say that for everything that is greater than 0.9, I want you to paint it white, everything else paint it black. So STY, and if I would render this, what do I get? Well, I get only the upper portion to be white and the rest to be black, just like how a step function works. But what happens if I multiply S times L? I get that, and that is that lines that I'm looking for, right? So we have the dashed lines. Well, what's next? We want to divide our space into a grid of 5 by 5. And how will you do that? Well, whenever you need to divide your space, think of the function fract. That function will divide everything into a grid of whatever size you want for example. So let's define a new variable. Let's declare a new variable, can define it, and let's call it FID fract st, right? Now if I were to render this, let's see what we get. What will be color float 3 FID, and that's a vector 2, so only one. And we really don't see nothing. Why? Because there's only one space. But if I zoom out, you're going to see how the fract function has actually divided everything into a grid of 5 by 5. So ST, and there you have it. So we have 5 squares horizontally and 5 vertically. So whenever you want to divide your space, use the function fract. All right. That's your function. Now, what if you want to not just divide it, but also be able to address a particular space? For example, what if you want to paint the space that is here? How will you address it, right? How will you identify it? Well, to do that, you can use the function floor. And I'm going to declare another variable called IID, and it's going to be floor ST, okay? And let's say that we want to paint the grid located at location 00 with the color blue. How would I do that? Well, all what you do is this. If IID.x is equals to 0 and IID.y is equals to 0, then set the color to blue. 0, 0, 1, and that will paint the 0, which is that one. I know you cannot see it, so let me paint it to red. So there you go. This one will be 2, 2 if we want to paint this one, right? And there you go. Why do we need this? Well, we are going to make use of this to position our dashed lines in only a particular section of where we want it to be at. All right. So let's do that. Let's do that. What we want is that for, so this is 0, 1, 2, 3, 4. What I want to do, I want to place my dash lines on the vertical axis at 1 and at 2. That's where I want them to be at. So to do that, I'm going to say IID that Y equals to 1 and IID equals to 2. And guess what? I'm going to take this out. I'm also going to get that out because I don't want to do that. And we are going to get what we created earlier, the dash lines. We're going to copy this and we are going to put it inside the if loop. And when we do that, you are going to see what we get. All right, now you may say, well, I don't see anything popping up, right? I don't see anything. Yes, I know. And that is because I made a mistake. It should not be and, it should be or, right? And this is what we get, which is not really what we are looking for. Oh yes, so what I did wrong here is that now we cannot be using the ST, we need to be using the FID, right? Because now we are using this particular space, not this space. So it's going to be FID for that one and FID for this one. And now we see our dash lines right in the middle. Now, I know this is, you cannot really see where it's actually located because it's so black. So what I'm going to do, and you don't have to do this, so I'm just going to add it right here really quick. So that way we can actually see some the axis popping up. So IDX. You don't have to do this, so I'm just doing this just to help us out. Color that B equals to 1 and boom. So now we can actually see the whole, some lines. All right, so what's next, right? We have what we want now. We have our dash lines and we have our space. And how did we create this? Well, basically using the function step, modulus, and then dividing the space and adding what we want in between these two coordinates, right? So now the next thing that we want is obviously we want to identify that if we ever step outside these lines, right, I want the lines to blink. All right, so before we move on, let me take a little break and implement the position of our player in this instance, so that way you can actually, we can visualize where the player is at before we make the lines blink. All right, so I'm basically just going to create a position here, float 2, and I'm going to make it 0, 0. And then what I'm going to say is if ID that x equals the position in the x coordinate and ID that y equals both that y. Or what I'm going to do here is I'm going to paint this with the color red. So it's going to be color, max, color, float 3, and I'm going to paint it with the color red here. All right, so basically that's the position of the player. And we can obviously manipulate where the player is at by simply moving this. What I'm doing is just referring to the index of the square. All right. Our whole point is that whenever the player is at the vertical height of 2, right, the line's not to blink, but whenever it goes beyond those boundaries, we want it to blink. All right, so now let's do the whole blinking. So to do this, we can either use the if statements. But usually when you are working with shaders, you do not want to use if statements that much. Don't ask me why. Some people say that you shouldn't. And that is totally okay, right? Because what we are going to do, we are going to implement the the if statements using the step functions, and we are going to implement the or statement also using the step function. So there are ways that you can implement the logical and or using step functions, and I'm going to show you how to do that. Right. So the first thing that we want to do is we want to say if the player is beyond, if the position of the player is greater than 2, or if the position of the player is less than 1, then blink, right? So if position that y is less than, let's say it's greater than 2, or position of the player in the y axis is less than 1, then I want you to blink, right? Then blink. So let's implement this. Float s1 equals a step. Remember how I told you that we can use step to do the if statement? Well, or what we do if it's greater than 2, but I'm gonna put some little bit of padding here, just for the heck of it. Well, not for the heck of it. It helps. All right. You're gonna see why. And then what I'm gonna do is pos.y. All right. Then let me do the other one where float s2 equals a step less than 1. In this instance, to implement something like that, what we are going to do is going to be something like this. And again, this website helps you a lot in actually visualizing what's going on. So the first function that we have is a step to x, right? And if we render that, we get something like this, which is obviously what we want. So for the other one, which we want to implement, which is for, in this case, y less than 1, how we implement that will be 1 minus a step 1x. And that will create basically the if statement that for everything that is less than 1, then it's going to go that way. So the way how you can actually create an or statement using step functions is simply by adding them. So if I do f1x plus f2x, what we get is what you're going to see right now, which is that. So just so you see what happened, f2, the first statement, which is x is greater than 2, is that way. X is less than 1, is that way. And if I add them both, if I add these two functions, what we get is the logical or function, which is if x is greater than 2, give me a 1, or less than 1, give me also a 1. And this is what we get. So we're going to implement it here. So minus 1.0 minus pos y. And again, I'm going to add a little bit of padding because I realized that helps in this particular instance. Okay, so now let's see if s1 plus s2 is equals to 1, then that means what? That means that the position of the player is outside the boundaries. In that instance, then what I want is I want the lines to blink. All right. But before we do that, let's just do something like this. Let me do color equals. Let me paint those lines with the color red. All right. So you see what I mean. All right. Let's change the position of the player. I'm going to come here and I'm going to make the position of the player to be at 0. What do we get? We get those lines. If we make it 1, we get those lines. If we goes to 2, we get a black. 3, black. 2, and even if we make it to 1, 2, 3, boom, there you go. All right, so we are almost there. Now we don't want to change them to red. What we want is to make them blink. And to make them blink, we again are going to use the modulus equation. which will return, basically will slowly ramp up to 1 and then drop to 0 and then 1 and then 0, right? So that's going to create that whole blinking effect. So let's just do that. Float m equals mod. In this case, we're going to use time. And what we're going to do now is the color, which is white, we're going to multiply it times m. And that is it. So whenever the player goes beyond, beyond the position, you're going to see how it starts to blink, right? But if it goes to 2, it doesn't blink. If we make it go to 4, it will blink again, right? Now, once you have this is basically all what you need to do. This is everything how that works, right? Obviously, after you have done that, you can come and apply that to an actual object, just like how I have it here. And again, by simply changing the position of the player, we can mess around with what's happening. In this case, I changed it to 5, 4, right? We're moving it, and will start to blink on and on and on. And of course, once if you can apply it to an object here, then you can apply it to anywhere in your game or in your game engine. And that is basically all what you need to do. You make use of 4 functions: the floor, step, fract, and the modulus function to create this cool, very simple effect. Alright guys, I hope you have enjoyed this video. I hope you found it helpful. And I also have this other effect that I've been playing around with. And if you want me to share this with you and show you how you can implement this, let me know in the comments below. And also, if you want me to do a live video, a live stream, so that way we can interact and you can ask me questions. If you want something like that, please let me know in the comments below. I hope you have enjoyed this video, and thank you again for watching this. Don't forget to subscribe to my channel and also join my Twitch channel. Subscribe to this channel and also join my Discord server, which I'm going to provide that link below. If you are an indie game engine developer, please join us. We are here to help you and also learn from you, right? We like to learn from you, and you can learn from us. Thank you guys for watching this video, and I'll see you next time.